So today let's take a look at what I have for notes for part 1. Science may be described as the art of systematic oversimplification. Okay? Karl Popper was a philosopher and a scientist who wrote a lot about the philosophy of science. Some of you may have encountered his work in other courses. Very interesting guy, very interesting theories, and we're going to look at a few of those through this unit. Okay, so in the natural sciences, again, when you probably heard we were going to be studying science, this is probably what you imagined it would be in terms of when you think of science, these are usually the things that often pop in most people's mind. That great scientists and scientific discoveries have been a big driving force in what has created the society for which we live in. Some could say that in over just the last 300 years, we have achieved some incredible leaps in science. I mean, just look at some of the things that have happened just in 300 years. From mapping DNA, to putting people on the moon, to discovering the periodic table, to splitting the atom, to cloning, to things like that, to the fact that you're holding in your hands often a computer that is way more powerful than one that was just around 20 years ago, and you carry it with you at all times. Is incredible, okay? On the weekend, I actually saw someone had posted on the internet a Radio Shack ad, a page from a flyer from Radio Shack from the mid-90s. And they said, your smartphone contains everything that's on this ad right now. Because it was an ad that had like a computer and like a voice recorder and a phone. Like it had everything on there, and it just showed how the smartphone had everything on that ad. And that was less than 20 years ago, and the progress that was made. So some might argue that that's the result of the natural sciences that we're studying, that this is a big driving force in achievement. Okay, as a result, because it has been so successful, it is often the model of knowledge. That people say, you know what, if you want knowledge, you go to the natural sciences. They're the ones that will drive getting knowledge more than any other discipline, okay? As a result, other disciplines try to mimic what the natural sciences do. So we had looked at human sciences and how, like for example, sociologists and psychologists try to do the same kinds of things that natural scientists do. So they try to do testing, they try to control the environment, they try to reduce the number of independent variables and things like that, okay? But with that then, it could be argued that there's still a way we can look at the natural sciences and kind of try to analyze what's going on there. And that's obviously what we're going to do in this unit. We're going to look at its strengths and its weaknesses, okay? And we won't take for granted statements like science has proven, okay? That statement alone can be analyzed for its worth, okay? And I'm not saying it's worthless, I'm just saying that we tend to sometimes just take statements like that as a given. Like, oh, okay, the scientists have proven it, and that's it. There's no more debate on the subject, okay? But we want to look at that, okay? We want to look at whether or not that is a statement that can be challenged. Okay, so for example, scientists have made statements. For example, physicists studied the baseball park in San Francisco, okay? And they did a lot of study on whether or not a baseball could be hit from inside the stadium, over the walls of the stadium, and into the San Francisco Bay just past the stadium. They actually put 2 years of research into this. So the physicists did lots of studies, they did lots of math, and they basically said that to clear that 24-foot wall and travel the 309 feet it would need to actually get in the bay, that they concluded that it would be impossible. And then Barry Bond did it 42 times. Now, one could say that there was some science that went into Barry Bonds. Anyone who's actually watched baseball knows that he was accused of steroid use. But nonetheless, scientists made a conclusive statement that the physics proves that a baseball cannot be hit outside this park into the bay, and then it was done. So there is a lot of history of science in the natural sciences being proved wrong, okay? And that's okay, right? That's an okay statement to make that. But it also makes us think about whether or not we should accept these statements all the time as given fact. The downside to that as well is this idea of possibly getting into a state of scientific worship. That we tend to, because it is so reliable, just take it as given. That when a scientist says something, take it to the bank, it's a fact, okay? If they're wearing a lab coat, you can trust them. What they're saying is truth, okay? And as a result, we should also tie this into ethics. Just because a scientist can do something, it's a different question from whether they should do something, okay? So the ethics in science is a big part of it as well, okay? Just as a side note, I put this little thing down there. Whenever you think of big budget movies, how are the scientists portrayed? They're often the, quote, evil scientist. And the scientists that in novels and in movies are often portrayed that way. Similarly, again, if you think about changes in the scientific paradigms over the years, it doesn't seem like there has been that many unless you go back a little bit, right? And a little bit more in the paradigms that what they were claiming was true definitely does change. Okay, when you cannot measure, your knowledge is meager and unsatisfactory. Okay, so this is Lord Kelvin. You guys may have known the Kelvin scale of temperature measurement. But again, he's talking about measurement. That in science, putting a number to things is important, which was what we did in our first activity, was trying to put numbers to things. So here we're going to do, again, a look at what is science versus what is not science. And the term that's often used when it's not science is the idea of pseudoscience, okay? So physics, chemistry, biology. Those are often just taken as a given that those are science. But are these technically science, okay? So we looked at some of these last time. Acupuncture, the belief that putting needles into the anatomy will restore energy, relieve pain, and cure you of certain things. Astrology, the belief that the position of the celestial stars, moons, and planets at the time you're born affects you. Creationism, the belief that the theory of evolution is false and that we were created by a God. Crystology, the belief that crystals have a magical healing power. And feng shui, the belief that the positioning of your furniture in your house can affect the balance and harmony of your life. Some of these we talked about, and some of these we placed on that continuum of science versus not science. And if science is taken seriously, then people who, if you disagree that these are science, and I believe a lot of you when we did this activity said, no, some of these are not science, these people will put science into their description. They will say that scientifically proven that Christology works. And advertisers will use the word science when they are advertising their products because it carries with it a certain amount of legitimacy. So if that's true, we need to kind of have that definition of what science is. We need to nail it down so that people can't misuse it. Here's some more. Graphology, the belief that analyzing a person's handwriting will teach you a lot about their character. Homeopathy, the belief that an extremely small quantity of a substance diluted in a lot of water will cause certain symptoms in a healthy person that can cure symptoms in an unhealthy person. And this one is difficult to pronounce. Phenology, the belief that the structure of a person's skull will determine their character and mental ability. Okay? Now, no one's saying that these aren't necessarily science. Well, maybe you could make that statement. But we need to be both open-minded, that maybe they are a science there, and also critical. And there's a balance there between open-mindedness and criticalness. In TOK, we tend to sway a little more on the critique side. We tend to analyze things, over-question things. Whereas when you go to your other classes, like in your biology class or in your chemistry class, you don't tend to challenge the teacher very often. You tend to be more on the accepting side, that you just accept the knowledge that's being given to you without challenging it, okay? Like, for example, if millions of people get relief from acupuncture, then is it working? Is it doing what it's claiming to do? If millions of people testify that, yes, it is in fact working to cure my pain, then maybe it is a science, and maybe it is a medicine, okay? If it works, then maybe we can study it the same way we study things in chemistry and biology. So we should have an open mind to some of this stuff. Whereas maybe graphology isn't working. So at the same time, we should be critical of it and sort of dismiss it based on certain claims. And that's, again, what maybe the definition of science needs, is this idea that maybe we can find a way to separate science from pseudoscience, but it's tricky, right? Is it just a matter of testing? Is it just a matter of, quote, whether or not it works or not? If it's working for you, keep doing it, right? Isn't that a quote from Dr. Phil? So again, it's an important question to analyze. What is science versus what is not science, and what should you take as science? You guys have been in public school for 12 years, and for the most part, you haven't questioned that. As you advance into higher learning, you're going to get more of that from professors at universities. They're going to want you to question stuff a little bit more, okay? It's kind of what separates a student who is at that sort of beginning level. The students are more at the advanced level. And that's, again, why the IB has put the TOK program in there, to start you down that path of sort of questioning existing paradigms. Because by questioning them, we often develop new paradigms. Okay, science is a way of thinking more than it's a body of knowledge. Carl Sagan, excellent program that ran probably before, I'm pretty sure before you guys were born. He passed away in the mid-90s. His program was recently, just last year, revived and is now being presented by Neil deGrasse Tyson, and the program is called Cosmos. Okay, for those of you who really are into the natural sciences, I would really recommend it. It's a great program. My daughter and I watched it it was on Sundays, but again, some really cool stuff if you're into the natural sciences. Okay, so let's look at those differences between science and pseudosciences, okay? One of them is that idea that we can test it. Can we test it if it's a science? And if we test it, what are some of the ways that we can protect ourselves within that testing environment to ensure success? Well, one is the idea of vagueness. If the results are vague, right, like, well, kind of shows acupuncture works and it kind of doesn't, then maybe we have less faith in it, or maybe, again, faith isn't, less trust in it in terms of its truth claims because of that vagueness, right? So, for example, we need, for example, time frames, right? Like you could say, yeah, Christology will work. It just hasn't worked yet. But over time, well, maybe we need to establish that time frame as to when it's going to work. And then the other one would be ad hoc exceptions. So there's always outliers when you do an experiment that, oh, look at this test result, didn't prove my point. But if there's lots of those ad hoc exceptions, then maybe we're not getting the right sort of data there, okay? All swans are white could be a claim you'd make. And then you encounter a black swan. And you go, oh, that's just, that's an outlier. It's just one exception. It's an abnormality. And then you encounter a second black swan, and then a third black swan. How many black swans do you accept before you claim that this statement isn't true, that maybe all swans aren't white, okay? That's, again, a good scientist will kind of balance the number of exceptions versus data that's kind of disproving what their hypothesis was. Okay, so in the natural sciences, hypotheses are sort of held tentatively. They go, you know what? I have a hypothesis, I've tested it, it appears to be true, but at any point I could be disproven, okay? And that's what good science tends to do, is they tend to hold on to things tentatively. They can say, you know what, it looks like this is the truth right now, but feel free to prove me wrong, and if you can, I'd be happy to accept your proof over my proof, okay? So it makes precise rather than vague predictions, okay? Again, science does that. It says this will happen, not something like this will happen. The predictions within science are often very precise. And it does not accept a lot of exceptions to experimentation in terms of the counterexamples. If a lot of things are countering its hypothesis, then it tends to drop that hypothesis. Okay, so that's our basic start at the natural sciences.